Hello, folks, and how are you all doing? So, I got some requests to make a video on AWS Lambda, and here we have one. So, in this video, we will make a very simple API using Lambda functions, and we will see how we can work with AWS Lambda. So, let's start by trying to understand what is AWS Lambda. And I don't like to give long lectures, so I have just asked ChatGPT, and we got a fairly good response. So AWS Lambda is a serverless compute service offered by AWS that allows you to run code without provisioning or managing servers. So this is what serverless is. So you write your code and all the deployments and everything is taken care of by the service. You don't have to worry about deployments or anything like that. And that is also one of the reason why serverless is so popular. So if you are using Next.js, you have the option to deploy using Vercel, and that is also serverless, and the simplicity is one of the main reasons why it is so popular. Now with Lambda, you can run your code in response events like changes in data in the Amazon S3 bucket, updates a DynamoDB table, HTTP request. I mean, you can use all the AWS services is what they are saying. So that is also AWS Lambda is very helpful because it is very well integrated with other AWS services. Anyway, so the key features are event-driven execution. So Lambda functions are triggered by events on AWS services, and this is something we will see in this video very soon. And it also has auto scaling and concurrency. So what this means is, again, you don't have to worry about scaling. In case you are using EC2, you have to take care of the scaling part, but Lambda will scale automatically. But the problem is when you have a lot of requests, generally serverless gives a huge bill compared to EC2. So that is one of the problems also. But yeah, I mean, technically you don't have to worry about auto scaling. And it is also pay as you go. Like the more you use, the more bill you will get, you can say like that. So in case of EC2, what happens is even if you are getting 5 requests a day, you still have to pay the bill. But for Lambda, it's not like that. Like it's basically you are paying as per request. So if I let's say search AWS Lambda bill or billing, whatever. So we have the pricing here, and you will see. Let's try to yeah. So this is the pricing as you can see. So uh, this is the dollar, lots of zeros and then 1 6, lots of 6 and 7 for every GB second and $0.20 per million requests. So for 1 million requests, you will have to pay only this much. And the duration is like for every GB second. Like, so it's a very, very low amount of bill in case you don't have a lot of requests. But in case you have a lot of requests in millions and millions, then this will be very high compared to the EC2. So that is the basic idea. And anyway, for the other things, it's a fully managed infrastructure. So AWS takes care of basically everything, infrastructure deployment, operating system, whatever. And it also supports many languages. That's given. And now how it works is we have to upload the code and we have to set some triggers. This is something we will see. And then we have to invoke, and that's all. So, so yeah, for basically for everything you can use AWS Lambda, and yeah, let's see soon. And also, let me ask one more thing: what are the cons? Let's see. It says we have some cons or not. So yeah, so this is one con you can say, and that is a cold start. So what is a cold start? So when a Lambda function hasn't been used for a while, AWS has to initialize a new instance of it, leading to a cold start delay. This can cause latency issues, especially in high frequency. So the impact is for workloads requiring very low latency, such as real-time gaming or live data processing. This delay might not be acceptable. So yeah, so cold start is basically, let's say you don't have a lot of requests. So what will happen is whatever the system is running in the background that AWS is managing, it is basically going to sleep. Let's say it's a computer and it is shutting down. So when you are sending a request, it has to turn on the computer and then send you the basically the response, and then basically do whatever it is doing. So this is what we call a cold start. If you're using another, let's say another software that is called Render. So Render is basically a cloud application platform, as you can see, your fastest path to production. So this is also like a hosting service, and here you can host your backend. But the thing is, in case you are using the free version, you will see something like a cold start. So cold start in that sense is it will first turn it on and then it will send you the response. So the initial turning on may take around 10 to 15 seconds. So for many of the things which you are getting for free, for hosting and other kinds of things, you may get a cold start. I mean, it's logical. They also have to manage and pay the bills, right? And then it's saying it's a limited execution time. So Lambda functions have a maximum execution time of 15 minutes. If your process requires longer runtime, Lambda alone may not be sufficient. Yeah, you can say that. And the limited control over the infrastructure. Yeah, I mean, this is both a pro and a con, you can say. So pros in the sense, if you don't want to manage, then yeah, that's good. But in case you want some control, for example, what is the OS and what are the other things, then there can be a problem. And there is a resource limitation, and that is AWS Lambda functions have limits on memory up to 10 GB. I mean, I think that is good enough. And dependency management, Lambda has package size. Okay, I mean, some other, but you can say mostly a full start can be one con. And another con, I think, yeah, cost for high volume. This is also a con. And that is while Lambda is cost effective for sporadic workloads, it can become expensive for applications that run constantly or have high free concurrency. So yeah, in those cases, Lambda will be pretty costly, and we have to find some other way. Anyway, so enough of let's say theory. Let's try to understand how Lambda works, and we will go to console, and here we have Lambda, or we can also search Lambda in the search bar, and let's go to Lambda. And what we have to do is we have to create a Lambda function. I already have a function to do's, and we will create another to do's function and see how we can do with some to do's. Yeah. So let's create a function, and let's give the function name as to do's. We already have this function, so let's write to do's API, and we will select Node.js 20, which is fine, and the architecture is x86. It's like our normal computer, and we will create the function. So let's wait for a while till the function is created. And we have our Lambda function to do's API. Now I have discussed about triggers. And here, as you can see, we have a trigger, which will basically invoke the function. And as you can see here, we have something like a VS Code, kind of a software in the AWS. And here we can write our function. So we will see how this works. But to see that, we have to add a trigger. So let's go above and click on add trigger. And in the trigger, we have to select the source. So the source can be Alexa, API gateway, and many other things. So this is how basically we will invoke our function. I will click on API gateway. This is basically one URL. Uh, and we will create a new API. And among HTTP and REST API, let's select the REST API. Security, let's keep open. And additional settings, I don't think we need to change anything else. API name is to do's API. Looks weird, but it's fine for now. And yeah, let's add. It may take a while. And yeah, we have our basically API gateway. And if I click on this one and configuration, we have this thing here. Let's copy, link copied, and I will open Postman. And in the Postman, I have Lambda, and here let me paste this thing and send. And as you can see, hello from Lambda. And it is coming from where? It's coming from the code. You will see hello from Lambda. And yeah, one more thing is that because this is Lambda function, we are managing everything end to end. Things may take a while sometimes. So for example, creating the Lambda to do API, it took a while. And also moving around the configuration test. The test is basically, sending some JSON, and this is like a normal test. Um, it's not required for now. But yeah, basically moving around these things, loading the code and everything, it may take a while, so we have to deal with it. So yeah, so basically, this thing works, as you can see. And also we will do the same thing here in the Chrome. We will post this, and you will see hello from Lambda. which means our Lambda function works and it's very simple. As you can see, we have to only write a function. And let's change this thing. Instead of hello from Lambda, we will do something else. Let's say this is a health checker API, and we write this all the time. So let's write API health is okay, okay, and success as true. Now, we cannot save directly, so we have to deploy our test. So I will directly deploy. We can click on this button, or we can also do Control Shift U, and again updating the function to this API. Deployment may take 2-3 seconds. You have to deal with it, and as you can see, API health is okay, okay. Success is true, and same we will get in Postman. So yeah, so that's good enough. Now let's try to build the to-do list API. This is only like one message. And also, as you can see, we have one function handler, and this is dealing with everything. So this is also a reason why AWS Lambda or serverless is also called function as a service. FAAS, fast, you can say. So yeah, if you have heard the name before, especially in AWS exams, you may get a question or two regarding this. So this is also called function as a service. So yeah, anyway, now let's write our to-dos. So how to write a to-dos API? So first of all, we will keep things simple today. We won't write too many handlers. We will only write a get, a post, and delete. So let's write a to-dos. This will be an empty array. And in the to-do implement, let me write beforehand. We will do a get. So get all to-dos. Then we will have a post. This will be basically post a to-do. And we will have a delete. This will delete all to-dos, not one to-do. And let's say in the next video, we will do the remaining. So next video, we will do a get. And let me also do a, what is that called? Let's say this is a to-dos. Actually, this is not to-dos. This is the to-dos API. So yeah, you can say that, this is something like to-dos with ID. And get, this is basically get a to-do. And then to-dos ID put. This will be edit a to-do. And then to-dos ID delete. This will be deleted to do. And right now what we have is basically for all. Yeah. And maybe I should remove the to-dos because it's to-dos API in a way. So yeah, so this is something we will take care of in the next video. For in this video, we will take care of the first part. So yeah. So how can we do this thing? So we have a to-dos, and now we will also have something called res. So this is our response. And then from the response, we will get few things. Uh, let's not get directly. Let's see what are the things we want to get. So we have API health is okay, okay, success is true. And after that, we also want to send the event. So this event you can see here, right? We will also send the event and we will deploy once again. And we will see in our postman what is the event. Because getting logs is little bit complex over here. It's possible, but it's a little bit complex. So let's directly get the event in our postman. Not recommended, but this is only for test. Yeah. So as you can see, we have the event. So we have a resource path, as you can see, is to-dos API. Resource is also to-dos API. HTTP method is get. So what are the things that we want to get? First of all, we want the HTTP method. So this is what we are getting here. So let's say, let me take this thing and let's do a post. So as you can see, the HTTP method is post. Yeah. So this is something that we will get. We will also get few more things. Headers we don't need. Multi-value headers not required right now. What we need is path parameters. So path parameters is null. Path parameters is basically, let's try to do one thing. To do API/a. Okay, send. And yeah, we are missing something. So this is not possible at this moment. So You can say that path parameters is when we want to send some IDs. And after that, we also need something called a body. So let's see, there should be something called a body. So here the body is null. But here, let's say we have to use this anyway. So let's copy and use this one. Send. Here, if you try to see the body, you can see that we are sending the 223 and whatever here. So we will need the body also. So these are the things that we will need from the event. So after the rest, let's take the things what we need. So HTTP method, path parameters we can also take. May not be required for now because we are not dealing with IDs, but yeah, anyway, you can get it. Is what I'm saying. Okay. Now the ID is something that we can get in the following way. Path parameters. If ID exists, we will get the ID like this. And yeah, this is Lambda. This is not VS Code. So we also have to give the semicolon like this. And now we have these things here. Now what we want to do is basically we want to get, then post, then delete. So first of all, let's deal with the get. So how can we get? First of all, let's do a try catch. In the catch part, what we want is basically some sort of an error message we want to give. So let's give res status code 500 and body, right? So body we will write JSON dot stringify and let's give some sort of a message. Internal server error. Basically something wrong with the backend. Internal server error and success is false. And we also have the error. Let's also send out the error. Yeah. So that's all. In case we have some sort of an error. And what we can do is we can remove this thing. And instead of that, we can send the res. Yeah. Okay. Uh, let's not deploy this thing. It's not doing anything right now. So first of all, let's try to get the to-dos and see what we can do. So inside the try, we will take a switch case, and inside the switch case, we will give the HTTP method. What this means is we are checking if the method is get or post or delete. Yeah, we just saw that we can get the method from the event. Now let's say we have the get method. It can be get. Okay, and this is not cast. This is case, and we will do a break. And then let's say the method is our post, then break 1 second. And lastly, let's say the method is basically delete. Then we will do something and also break. And lastly, there will be a default case. And again, a break. Now in our get, what do we want to do? We want to basically send out our to-dos, right? So let's create a response. So what will be the response? So first of all, status code as usual. This is a good response. So status code is 200 and body will be json dot stringify and we will basically send the to-dos success as true, and let's also give a message. So message will be, let's say, what can be a good message, send to-dos, something like this. And yeah, let's deploy. We don't have to-dos right now, so it's an issue. We will get an empty to-dos, that's it. So let's copy this URL. Let's go to to-dos, get to-dos, paste, send. Let's see. So send to-dos, but the to-dos is empty and success is true. Seems good. So what we can do is we can create a dummy to-do for now. So here, let's give an ID of one. Then let's give a name. Name we can give as write Python. This is a to-do and completed is false. because we are not writing Python, we are writing JavaScript, and that is also in a Lambda function. Okay, so now uh, we can have an agreement that the to-dos will only send this one to-do, that is write Python. We have to write the post case to also post the to-dos. And also we haven't written anything in the default case, which is also required. And this is, let's say when somebody is trying to do a put or something else. So here what we can do is we can create something like a status code as status code 405, and body will be json.stringify, something like method not allowed. You may be wondering why I'm giving all these random status codes. It's not random. Every status code has a meaning, and you can get these meanings very easily. Status code meanings. Uh, I think in W3 schools. I mean, if you are using a lot of status codes, this is pretty basic. But if you are a beginner, you may wonder what is the meaning of each status code. So this is what they mean. So 405 is basically method not allowed, and that is basically what we are trying to do over here. So these are all methods. If somebody tries to do a put, we will say that method not allowed. So message is method not allowed. And success is actually false, because by success we mean what they're trying to do. For example, if they are sending a put, they want to put. That is not allowed. Yeah, and let's close this thing because we know the command, and let's have some more space. I don't like, you know, taking up the space. Very bad, very bad. Okay, so now let's write the post also. So in the post, what we want to do, we want to create a new to do. So const new to do, new to do. And what is the new to do? So the new to do will first of all take information from the body. What is the body? The body is whatever we are taking from the event. So JSON dot parse body. This is our new to do. And then we also need some sort of an ID. So new to do dot ID. What is this? So we will take a random ID. So math dot float and math dot random, and this will create a number in between 0 and 1, so multiplied by 1000. So the id is a number in between 0 and 1000, that's all. Lastly, we will push this new to do inside the to do, so to do's dot push new to do, and then we have to create a response. So the response is status code 201, not 2021, the notorious covid year, and json.stringify, and let's give a message. The message is what is the message? New to do added, something like this. Success is true, of course. Yeah, let's deploy and let's see what we can do. So let's go to Postman once again and let's go to our to dos. So send. We have write Python. That's good. Now here, let me create a to do, and that is write Lambda. Completed is true. Almost true. Still not true, but it will be true soon. So new to do added. And if I go to get to do and send, as you can see, we have another to do write Lambda, and the ID is 385. Good enough. Good, good. And one issue we found is here we should ideally send the to do also. So let's go to the Lambda, and success is true. And after that, let's also send new to do. Yeah. And now let's also write the delete. So the delete here, we will basically make the to dos as empty, and then we will create the rest. So status code will be 200, and body will be json dot stringify message all to dos deleted. So this is like the clear all button in our to do list, you can say. Success is true. And also send all the to-dos. That's it. So let's deploy and let's see. Everything will work. This is so simple. So health. Okay. So in health, we have an internal server error. Possibly because, possibly because, yeah. The reason is very simple. Let's go over there once again and send. And we have an internal server error. Uh, Looks little bit strange. If I do a send here, we have the to-dos and this, yeah. So the reason is we are posting, but we are not basically sending any body. That is the reason. So if I do a delete, you can see all to-dos deleted. Now if I do a get to-dos, you will see to-dos as empty. So yeah, that is the reason. I mean, very silly, stupid reason. Now if I do say, I mean, you can see the to-dos is empty. So yeah, anyway, all to-dos deleted, but let's see we can enter to-dos or not. So our Lambda function is complete. So send this one. So write Lambda, ID is 65. Now write JS, send. Now we have to, uh, yeah, this is only the new to-do. So if I go to get to-dos, you can see I have write Lambda and write JS. Both are true. IDs are different. And which means our Lambda function is working perfectly fine. And you have just seen how easy it is to create a Lambda function. So we have to create a new function in the AWS Lambda. We have to add a trigger, uh, usually the API gateway, and we have to write the function. That's all. Now, I won't make this video more complex. That's what the next video is for. We will add like the get post and delete. I mean, not post, I mean, put and delete whatever by ID. We will see how we will get IDs and basically we can do everything on the Lambda also. Uh, it's not a big deal. Only thing is we have to keep the bills in mind. Let's not get too many requests and we won't get any bills. So yeah, that's how the Lambda function works. And we will also do one more thing. We will use AWS S3 and AWS CloudFront, and we will create a front end. And we will see how we can host the backend in Lambda and front end in S3. And yeah, that will be another video on AWS front end. So yeah, that's it for this, folks. So and let me also know in the comment section below, like you have did for this one, what more topics you want to see on AWS, on Golang, or any other things. So yeah, and I will try to make a video on that. So that's it for this, folks, and I will see you next time with another very interesting AWS video. So see ya.